Welcome everyone, and thanks for attending this evening's webinar. My name is Talia Newton. I'm the Climate Emergency Project Officer at Basco Shire Council, and I'll be your MC for tonight's webinar. I'd like to start tonight by acknowledging the Bunurong and the Gunai Kurnai peoples as the traditional owners and custodians of the lands and waters that I'm currently on, and I'm sure that many of you are too. I pay respects to their elders past, present and emerging, as well as Aboriginal elders of other communities who might be joining us tonight. If you're joining us from elsewhere in Victoria, feel free to introduce yourself and acknowledge the country you're joining us from in the chat. Tonight's webinar, Introduction to Solar, is the first in a series of webinars that Bass Coast and South Gippsland Shire Councils have partnered with Renew on across 2025. Renew have been working in the sustainability space for over 40 years as an independent, not-for-profit body with a mission to inspire, enable and advocate for people to live sustainably in their homes and communities. This webinar and all the other webinars will be recorded and made available on the CAP, the Community Action Portal, for future viewing. The 2025 webinars are designed to equip you with the information and knowledge to make your homes more comfortable, energy efficient, cheaper to run and more environmentally friendly to live in. Now, without further delay, I'd like to welcome our expert presenter tonight, Andrew Redaway. Andrew is an energy analyst who's been involved with Renew for 10 years, helping households with independent energy advice. He's also worked for the Australian Energy Market Operator, the Australian Energy Foundation and NHAR. He is trained in solar installation and is a certified passive house designer. Thanks, Andrew, and over to you.
Yeah, thanks a lot, Talia. Great to be here doing another webinar. So, interesting topic tonight, solar. So this is introduction to solar. So we're looking at mostly assuming no prior knowledge, basically. So there shouldn't be anything that's got too much jargon or too many sort of really confusing concepts or anything like that. So hopefully that's going to help people out. So why solar? How does solar work? Look at rebates and feed-in tariffs in a little bit of detail. So it's on the financial side. How do you get the most out of your solar when you have it? Have a quick look at batteries, not in too much detail because we do have a whole extra a whole webinar which I think is on the list for solar and batteries, and yeah, buying a solar system at the end. Okay, so before we really get into the solar, let's just talk about electricity bills a little bit. I know electricity bills are not the most fun subject in the world, but pretty much everyone has one, and so it's good to minimise if possible. And the first thing to do, whether or not you have solar, is just have a bit of a review and see if you're on a good deal with your electricity retailer, so the company that sends you your power bill. And one simple thing is just to send them a message or call them up and say, okay, am I on your best deal? Because like with a lot of things, like, insurance and other types of utilities and stuff, unfortunately, these days, the companies have gone to a bit of a loyalty tax. So if you've stayed with them for a long time, they don't reward you for that by giving you a good deal. They think, oh, we might be able to fleece this person for to get some more money off them because they're not really paying attention. So if you're on an old plan, then they tend to raise it up little bit by little bit. So unfortunately, it does put more effort on the householders, on the consumers, to have to continually look for better deals all the time. And then that's not just electricity. So yeah, just ask for a better deal. Or the other thing you can do is shop around with different electricity retailers. And the easiest way is Victorian Energy Compare. So that's provided by the state government. And so it's a trustworthy comparison website, and it's pretty comprehensive. Some of the comparison websites are not that great because they may only be showing you offers from retailers who are paying them to be included on the list. So it may not be a comprehensive list that you're getting access to. So yeah, this is a pretty good one, and it's easy to use. You're basically going in there and putting in some simple information about like off your old bill, like how much energy you're using, that sort of thing, and it'll pop up with a list of different plans and different offers that you could switch to with different companies. So there's that. Whatever is a commercial site that's reasonably good. So that's another one that you could consider. And apart from getting a good deal on your electricity, then don't forget about saving energy. So the best energy that you don't have to pay for is the energy that you didn't use in the first place. So what we're looking at here in the picture, this is up in a roof cavity. So we've got the ceiling at the bottom, and then we've got the roof at the top. So it'll probably have ColourBond steel or tiles or something. And what we're seeing at the bottom level there is insulation bats. So it's a nice thick layer of fiberglass material, and that's a nice warm blanket on top of the ceiling. So in winter, your heat isn't going to leak out through your ceiling as quickly, right? And in summer, it's going to be harder for the heat from the sun to soak through into your living spaces. So that's just one example of energy efficiency, but yeah, ceiling insulation is a pretty important one. So yeah, we have whole presentations on these topics, but what you could do is get somebody to stick their head up through a manhole and have a look in the roof cavity and see what sort of insulation you have. Is there none? That's possible. Or is there some, but maybe it's all been shifted around by electricians when they were doing some work, and there are places with no insulation, and there's places where it's just heaped up. So that's not very effective. So yeah, and the other thing we see here is underneath the roofing material, we have this silver foil. So that also helps to insulate the home. It reduces how much air is leaking through, like in between the tiles, for example, or in between the joins in the metal sheets. But even more importantly, it's like a reflective layer. So yeah, if your heat is more likely to bounce off like a silver reflective surface, and it's also a lot of people don't realize, but if that silver surface gets heated up, so like say it's a 40-degree day and the roof surface is, I don't know, 50 degrees or something. So this silver material might be 40 degrees, but it's not going to radiate heat out so much because it's reflective. So it works both ways, like both it doesn't accept heat and also doesn't emit heat very much. So that's just a couple of examples of a fairly efficient insulation for your roof. And the roof is your roof and ceiling on top of your house is probably your first priority with insulation. And then you look at the walls and windows and doors, and then you probably look at the floor. It is just a sort of standard, like generic thing. Like each house is different, and if you've got a specific issue, like you've got floorboards with gaps between them that are like really big, then yeah, that might be your first priority. And yeah, another example over here is just a energy rating star label. I bet you've seen this before somewhere. Yeah, you've seen it on white goods usually. So if you're buying a new fridge or a washing machine or whatever in a retail store, like a physical store, then it'll have one of these labels on it. And so the more stars, the better, because it's using less energy when it's running. However, as always, it's not quite that simple. Like, let's say you had an old fridge from 15 years ago, and you look at the star rating and it says, oh, 5 stars. I think that's pretty good. And then you go into Harvey Norman or Good Guys or whatever, and you look at a new fridge, and it's similar size fridge, and you look at it, it's got a star rating that says 4 stars, and think, whoa, that's terrible. Like, we've got this new fridge, and it uses more energy than the 15-year-old one. Well, it probably uses less, but the reason why it's got less stars is because the standard has been made tighter and tighter over time. So yeah, a new fridge with like 4 stars, that it probably is a lot better than a 15-year-old fridge with 5 stars. It's a bit like the crash ratings for cars, I guess. Like, yeah, if a car achieved 5 stars like 20 years ago, then on the ANCAP like safety ratings, then it probably still isn't as good as a new car coming out now that has 4 stars like safety rating, because the tests now are so much more stringent than what they were back then. So if you really want to compare, then the best thing is to look at this number in the label. So that's actually how much energy it would use per year, assuming like a standard usage for that appliance. Like, you know, if it's a fridge, you're not opening the door every minute of the day, and if it's a washing machine, then you're just doing a typical number of washes per week, that kind of thing. So that's the best way to compare. Now, what is that number actually talking about here? What units of measure? Okay, so if we're talking about distance, then the units of measure would be kilometers or meters or centimeters. If we're talking weight, then that's kilograms or grams or pounds or whatever, if it's like in the US or something. But if it's energy, then usually this is the unit we're using, kilowatt hours. So you don't have to worry about what it really is, but it's just it's a unit of energy. And if you look on your electricity bill, then there'll be information in there that says, okay, we're billing you for 30 days, and over this 30 days, you use 300 kilowatt hours of electricity. So yeah, it's just a unit of energy. And so just to give you an idea, if you ran a microwave oven for an hour, well, I wouldn't want to see what the food looks like when you open up your microwave after that, but that would probably use about 1 kilowatt hour of energy. So yeah, just gives you an idea, I guess. Oh, and like a typical Victorian household would probably use around 15 kilowatt hours per day. So yeah, there you go. All right. So solar. There are different reasons why people get solar systems on their roof. Sustainability, environmental benefit, that's important to some people. And the way that it really helps is because if you're generating your own power, then that means you're not importing from the electricity grid. And when it comes to the electricity grid, it's a bit of a mix, but it's unfortunately in Victoria, it's still mostly fossil fuels. So yeah, if you're generating your own clean power, then that means you're not causing those lumps of coal to be burned in the Latrobe Valley, or those molecules of gas to be burned in other parts of the state. And if you're generating more than what you're using, then the excess will get sent into the grid, into the poles and wires, and that will go like around the corner and into someone else's home, and then they'll be using it. And so it's doing the same thing for them. So even though they don't have solar, then they're now getting clean electricity, which is reducing how much coal has to be burnt. So that's the environmental benefit. Now, yeah, this is changing as the grid is getting greener, getting cleaner, which is fantastic. So if there are times when the Victorian grid is pretty much running on wind and hydro and solar and batteries, then in that case, well, your solar, it's not actually doing that much environmental good at that point in time, because if you were importing from the grid, it would be clean anyway. So yeah, that is a consideration, but yeah, most of the time it's still doing good work to reduce fossil fuel. Oh yeah, and we sometimes get asked, what about all the energy that it took to manufacture the panels? Because we've got aluminium, so that's very energy intensive, and you've got glass on top. That takes a lot of energy to melt the sand basically to make the glass, and then you've got the silicon cells, the crystals, that uses energy as well. So that's a valid question. And then there's transport. Like most of the panels come from China, so they've got to be shipped on a ship that's probably burning bunker fuel or something. So yeah, valid question. From an energy point of view, there's been a lot of studies done, and yeah, so if you look at how much energy it took to make the solar system, to manufacture it and ship it, well, the solar system, if it's been generating on your roof for 2 years, then it's already generated enough energy to cover all of that. So yeah, that's pretty good. Most people have their solar system for a lot longer than 2 years. So yes, they do produce a good, positive environmental benefit. Economics, another reason why you get a solar system. So if you're using your own electricity, then it's basically free at that point in time. Which means you're not paying for electricity from the grid at that point in time. So you may be paying like 26 or 30 or 35 cents for electricity coming from the grid, depending on what kind of plan you're on. It might vary from like evenings to mornings and that kind of thing. So that's a direct benefit. And then if you are exporting to the grid, then you're going to receive a feed-in tariff, and I have slides on that later on that we'll talk in more detail. But when you take all that into account, like how much you pay for a typical solar system, how much upfront. So maybe you pay like $5,000 or something for like say 14, 15 panels on your roof, and then how long would it take you to save enough money off your electricity bill to get back that $5,000, say? I'm just talking rough sort of averages. And it varies. So the chart here is showing different cities. And so in Melbourne, we're looking at maybe 8 years to achieve payback. And yeah, that's about right. It's an old chart, but I just checked it before the presentation with a calculator based on the Bass Coast area. And yeah, about 8 years would probably be about right. Now that's just assuming everything's sort of standard and typical. You could achieve faster payback, like if you use a lot of electricity, especially at sunny times, then you'll get payback quicker because you're using more of that solar directly and saving that 30 cents or whatever per kilowatt hour from the grid. And the location does matter as well. So Adelaide, South Australia is a lot sunnier than Melbourne. So yeah, you're generating more with the same panels. That's one of the reasons why you'd get a quicker payback. So payback time is one way of looking at it. And another way is to say, well, how does that compare to, if I was to take that $5,000, for example, instead of buying a solar system, what about if I just put it in a high interest bank account? Well, that's a good way of looking at it as well. So it's a bit different. Like with solar, you get your bill saving every year. With your bank account, you get interest every year, and you get your money back when you withdraw it, right? But you don't get your $5,000 back when you take the solar panels off your roof, unfortunately. Um, so comparing those, you have to be a little bit careful. But yeah, that's the best way is with a accounting method called internal rate of return. So that is like an equivalent interest rate on a bank account. So typically, if you look at solar, you'll get it'll come out to say 15% or 20%. So what that's saying is it's like the benefit that you get, like over say a 15-year period on your roof with the solar, it's equivalent to like if you put money in a bank account that was earning like 15% per year interest. So that's, if you look at it that way, it's pretty good. And disclaimer, I'm not an accountant or a financial advisor, but if you're putting money in a financial investment, then you typically have to pay income tax on the interest or the dividends that you get back, right? So yeah, but if you're paying for a solar system and you're getting bill savings, you're not paying income tax on your bill savings. So that gives you an extra benefit again. This is just looking at the prices of solar systems. So this is not saying that a solar system costs $2.40 for your whole system. It's just like a taking it back per panel, basically, per solar panel. It's actually per watt. It's just like a solar panel might be 400 watts of rated power, for example. So back in 2012, it was way more expensive than it is now, and prices came down a lot. So that was better technology, ramping up of the scale of solar manufacturing facilities, and China as well. So yeah, that's so by 2020, prices were down to a pretty low level, and they've sort of bumped around a similar level since then. So yeah, the solar price is doing well. So here's a current example. Oh, sorry, just trying to move my little screen here. So this is okay, let's look at a 6 kilowatt solar system. So that would be about, say, 14 typical panels. So that would be, it takes up a fair bit of roof area, but if you've got a decent sized house with a good spot to put it, then that would be a pretty typical sort of size for a lot of homeowners. So unfortunately, it's Melbourne rather than regional. So regional locations, you may expect it to be a bit more expensive, as like a lot of things are compared to the capital city. But yeah, so you're looking at around $5,000 for a 6 kilowatt, say 14 solar panel system. So that's actually pretty cheap. Okay. So the lowdown. Okay, just some stats for you, basically. So we're talking about panels that generate electricity. There are another type of solar panel that generates hot water, and we're not talking about that, just so you're aware. And then those normally, you can tell because they've just got like 2 panels side by side, or maybe 1 panel. And sometimes they have the horizontal water tank up above them as well. So yeah, that's a whole different story. We're up to almost half of homes in Victoria that are suitable for solar. I think that's basically excluding apartments and excluding renters. Now, rental homes, yeah, if it's a detached house with a nice, suitable roof, then yeah, that's actually very suitable for solar. But unfortunately, it can be tricky to make it happen because the person who owns the system, like it's part of the house, so that's owned by the rental provider, the landlord. But the person who gets the benefit is the resident or the renter, the tenant. So they're the one getting the electricity bill, so they're getting the benefit of that asset. So it's called a split incentive. So you've got you've got one person paying for it and someone else getting the benefit. So how do you make it like in everybody's interest? So there are ways to get around that. And it can be as simple as just if you're a renter, if you have a property owner who's reasonable to deal with and you have a direct communication with them or through the real estate agent, then you may be able to come to an arrangement. Say, okay, yeah, look, I don't mind if you put up the rent by this much if you put the solar panel on, the solar systems, because then, okay, my rent goes up a bit, but I'll save more overall because my electricity bill goes down by more. So, I mean, that's one way to do it, and there are some other sort of ways to get around that as well. So generally, yeah, it's a pretty good return usually. So in terms of batteries, so a battery is an optional add-on to a solar system. You don't have to have a battery. Most solar systems they call it the attachment rate. Like if you're buying a new solar system and installing a new solar system, what percentage of those are getting a battery at the same time? And I think it's like a quarter or it's somewhere around that now. So it's still a minority because batteries are still fairly expensive, like compared to the benefit that they give you. Yeah, so that just gives you a rough sort of overview. Oh yeah, and that 43% in Victoria. In other states, it's higher, like South Australia, Queensland. Yeah, they're really going gangbusters. Okay, let's talk about how it works. So typical house, we've got the poles and wires here, the grid. You've got your cable that connects you to the grid. So if you don't have solar, then electricity flows from the grid into your switchboard and your meter, and then from there it goes out to the rest of your house. Now, this house has solar and it's sunny, so sunbeams are hitting the solar cells and the solar panel, and it's knocking the electrons. It's pushing them down the cables down to this box on the wall, which is called an inverter. So that changes the solar type of electricity into the correct type of electricity that's compatible with your appliances in your house and the grid. So that's going into your switchboard, and then from there it flows out everywhere. And because the arrows are pointing back towards the grid, that means that, yeah, you've got appliances running like your fridge, your TV, air conditioner, whatever. But in this case, the solar panels are generating more than that. So your appliances have the first call on any electricity that you're generating from your solar panel at any point in time. And then if you're generating more power at that point in time, the excess will automatically go back to the grid. You don't have to do anything. It just happens. Oh yeah, sorry, I've jumped ahead. So panels, inverter, switchboard, yeah, consumption in the appliances. The grid, I started with that. Why would you do that last? Weird. Okay. All right. So rebates. Okay, it's missed. Not sure why we don't have a slide on the first rebate, which I will talk about. So there's a so when we talk about rebates, it's basically like a government incentive for putting in solar, so a financial benefit. And there's one rebate that everyone gets. Like you don't have to have any eligibility criteria or anything like that. And that's called the STC, like Small Technology Certificate. You don't have to worry about about the details because it's just automatic. Okay. So if you get a quote from a solar installer and they're quoting you $6,000 or whatever, then that quote will already be factoring in that STC rebate, and that's a federal thing. It's all over Australia, so it's automatic. And with those solar system prices I mentioned previously, it was factored into those as well. So that's great. The only thing is it is reducing a bit every year. So in 2030, it'll all be gone. You'll have a zero rebate, and it's already half gone. Like over the last 5 years or so, it's been phasing down already. So that's that. If you're going to have a rebate system, it's better to phase it out gradually because over the last 15, 20 years, like I've seen it so many times that you like when you've got this rebate and then the government, like federal or state, says, oh, we're changing it, the rebate's going to end in 3 months' time, then everyone piles in, oh, quick, I have to install my solar so I get the rebate. And the solar installers are super busy and stressed out. And then when 3 months comes, then they have no work. So yeah, we don't want that. That's the solar coaster, the boom and bust. So yeah, a gradual phase out is good. So if you have a solar salesperson saying, "Oh, you have to jump in now because the rebate's going," well, you don't have to worry. Like it's phasing out so gradually that it doesn't matter. Yeah. So that's the federal rebate. STC, it's just automatic. Now, in Victoria, the state government currently has another rebate. So this is $1,400. And this one, yeah, not everyone can get this one. So you can't earn too much as a total in your household, and your home can't be too valuable, and you can only get it once. Like if your home has already got this one, or the battery one, or the hot water one, like the state government has a few of these. If you've already claimed one of those, then you can't get it again, unfortunately. Yes, you can get it as a rental, which is great. So with this one, your solar retailer, the company that you're buying the solar system off, they manage this process for you. So again, you don't really have to worry about it, but still check that they're doing it. And on top of that, you can also get a interest-free loan. So instead of finding the money up front to pay for your solar system, well, you still have to find some of it up front, but some of it you can pay it back over 4 years. So yeah, that's pretty good. Okay, so feed-in tariffs. So yeah, whatever solar generation your house doesn't use at a point in time, it's fed into the grid. Okay, and you get paid for it probably. So the example here is saying 5 cents. Okay, so let's say from 12 midday to 12:30, half-hour period. Let's say you export 3 kilowatt hours of electricity back to the grid. Then if you're getting a feed-in tariff of 5 cents, then you would earn 15 cents in that half-hour period. Sounds like not much, but you know, if you add that up over 365 days times multiple hours times multiple kilowatt hours of energy, then that can actually have a reasonable improvement in your payback. Okay, so what feed-in tariff are you going to get? Okay, that depends on your electricity retailer and what plan you're on. So you could be with like Origin Energy or AGL or Sumo, Dodo, Bilbo. Like there's 1,000 different electricity retailers now to choose from, and they all have multiple plans, right? So So you can find some plans, like if you go in the comparison website I mentioned at the start, that will say, okay, we're offering a really good feed-in tariff. We're offering a 10 cent, 15-cent feed-in tariff. Sounds great, but you still have to check, well, if they're being really generous on that side, maybe they're going to charge you a lot when you are importing electricity from the grid. So just check out that they're not like giving with one hand and taking away with the other. And so how do you receive that? Well, yeah, when you get your electricity bill, well, once you've got solar installed and it's all been signed off and the paperwork's been done by your solar installer to with the poles and wires company. So it would be AusNet in around the Bass Coast area. Hang on, Powercore, one of those. Then so when you get your electricity bill, it will say on there all the usual stuff. You've imported this much electricity from the grid, and we're charging you 30 cents per kilowatt hour, so you have to pay this much. And it'll have a new section on there that says, they usually call it generation or something, solar production. It's actually what you've exported to the grid, right? That's not your whole solar generation. They only know what you've exported. You've generated a lot more than that, and you've used a lot of it in your own home, and they don't even see that. Okay, so they'll say, okay, you've exported to the grid X kilowatt hours, and so as based on the feed-in tariff of 5 cents or whatever it is, then we're paying you $50, $100, or whatever it is on this bill for that. Okay, so some people look at that on the bill and they go, oh, my solar system only gave me like a $30 benefit this month. That's not much. I thought it was going to be better than that. But just remember, you're only seeing the portion of your solar generation that's exported, because that's all that they know about, what's gone through your billing meter. There's a whole extra benefit which you don't see itemized on your bill, which is the electricity you've used in your house that has meant that you haven't had to buy in electricity from the grid at 30 cents or something. So yeah, so there's two benefits from the solar, and on the bill you can only really see one. Okay, so let's talk about this amount for the feed-in tariff. It's changed a lot over time. So if we look at a timeline back to 2008, well, those were the good old days, huh? You could get a feed-in tariff of 60 cents. Yes, but if you got a 5 kilowatt solar, or say a 6 kilowatt solar system, 14 panels, well, in those days, the panels were smaller, so it was probably more like 30 panels you'd have to get just for the same power. You probably would have paid like $30,000 for that solar system. So that's why there was a generous incentive then, because you needed those early adopters to take the hit and pay those expensive prices up front for their solar system, so that it kickstarts the industry and you start getting those economies of scale. So that's all good. And that's basically gone now. Like it's pretty soon this year. If you did install solar like prior to 2011 or so, then you can still be on this now, but it's about to disappear soon this year. Then there are other feed-in tariffs. If you installed solar in like 2012, 2013, whatever. But ever since then, I mean, that's ancient history. If you're installing solar since then, it's not like that. Now it's a variable rate, like I guess like a variable rate mortgage. That's topical, isn't it? It changes regularly, and it's basically up to the retailer, your electricity rate retailer, to set what that feed-in tariff is in your electricity plan, like on your bill, your deal. But there is a minimum which is set by the Victorian government. Well, actually, it's the Victorian Essential Services Commission. So every year they do an analysis and they come out and say, well, how much is solar electricity actually worth to a electricity retailer at the time when it's sunny and solar is generating? And so they've come out with these minimum amounts. So it's bounced around the 10-cent level, but recently it's plunged down to 5 cents, 3 cents at the moment. And they came out and announced not that long ago that what their recommended minimum rate it's like their draft result is from July this year, it's going to be 0.04. I mean, it's so close to zero, they might as well have just set it to zero, huh? But they've got their methodology that they stick to. So a lot of people look at that and they go, "You've got to be joking! Like you're saying that when I'm buying electricity from the grid, I'm paying 30 cents, and when I sell electricity into the grid, I get virtually nothing. Like, how can that be fair?" Well, yeah, when you look at how everything actually works, there actually is a lot of logic behind that. And it actually probably is, like, with the way our market works at the moment, it probably is fair. And I could explain that if someone wants to ask a question about it later, but in the interest of time, I think I might have to keep moving. Yeah, so basically, if you're installing solar now, this is probably still going to jump around. Like, things are changing in the energy system, right? Your Lawn Power Station is going to close in, what is it, a couple of years. So when that happens, things are going to change again. And also, one of the coal-fired power stations in New South Wales as well. So when they close, then that's going to change the supply-demand balance in the system, and probably the feed-in tariff will jump up again. So, but basically, I wouldn't be assuming that you get much revenue from excess solar that you're exporting into the grid. Like, just look at that as a bit of a bonus. Really, the game now is about solar electricity that you're consuming in your appliances when it's sunny, at the same time as your solar is generating. Yeah, here's another factor. So when you're getting a solar system, so your solar installer will put in an application with your electricity poles and wires company in your area. So they're going to say, well, okay, putting in a 60 kilowatt solar system, how much are you going to allow us maximum power to export into the grid at any point in time? And the poles and wires company will come back and say, okay, with our grid, yeah, no constraints in our area. Your area is all good. Yeah, you can export at 5 kilowatts maximum. Okay. Or they might come back and say, oh, actually, yeah, the poles and wires and the transformers in your area, they're a bit under pressure sometimes. Like, there's bottlenecks in our network, and if too many people export solar all at the same time, it's going to overheat our transformers and bad things will happen. So, sorry, we're only going to allow you to export 2 kilowatts maximum power back to the grid, just as an example. And there have been cases where they've said, no, you're not going to be able to export anything, in which case your solar installer would put a setting into your solar inverter. So when your solar system's about to reach a level where it's exporting to the grid, then it's actually going to back the panels off, and so your panels don't generate as much. So it's never going to actually export. So yeah, that's not a great situation. I mean, we want more clean solar, right? But it's true, like, some areas do the poles and wires do have physical constraints. Like they weren't designed for every house having solar and like all trying to push it through the bottleneck at the same time. So there are constraints, but the best fix for this is actually to have a variable export limit. So instead of like if they come back and say, you know, you can't export anything or you can only export 1 kilowatt, that's like a very blunt instrument. A much better way is to say, well, okay, you can export 10 kilowatts or 5 kilowatts, but only on the condition that we're going to send a signal, like the poles and wires company will send a signal to your inverter, like just at times when the network actually is like getting stressed. So it would only be not very often, but at those times, then we'll tell your inverter to back off. So most of the time you can export. Like for example, if it's a day like today, for example, so the weather's mild, people don't have heaters on, they don't have air conditioners on. It's sunny. So yeah, that's the kind of day when, if you think about your local street, people aren't using much electricity, but there might be a lot of generation that could have a bottleneck and want everyone to reduce. But if it's the middle of summer, everyone's got their aircon on, then totally different story. Like your poles and wires company would love to have that solar generating and exporting, so it's going around the corner into your neighbours, because that's taking the pressure off all their infrastructure that's struggling to deliver all that power to all the aircons. So yeah, like a flexible dynamic system is better, and that's coming. So all the solar systems being installed now are already capable of doing that. So that's good. All right, a few frequently asked questions on the solar side. Panel tilt, like should it be flat? Should it be like 30 degrees? Well, should be probably between 20 or 30 would be the optimum, like for generation over the whole year, like maximum energy generation if it's facing north. But in reality, it doesn't matter that much. Like if it's like 10 degrees, that's fine. 5 degrees, yeah, it's fine. Flat is fine, but if it's flat, then it's a bit less likely to need cleaning, which I'll come to. Orientation, like north or east or west or even south. Yeah, again, look, it doesn't matter that much. North facing on a tilt will be the best for winter. West facing is going to be great on summer evenings. So the sun's setting in the west, and it'll be going nicely on your solar panels, which is probably when you might be running your aircon. You know, those hot 6 p.m., 7 p.m. on a summer night, then that's pretty good. And then east facing, yeah, that's going to be summer mornings. So again, pretty good. South, it's actually kind of okay. Like it does okay in summer, not so well in winter, but in winter, you sometimes have like days when, you know, when you look up at the sky and you can't tell exactly where the sun is, like you've just got this sort of grey kind of shine over the whole sky. Well, in that situation, it doesn't matter which way the clouds are pointing, because it's basically the whole sky is providing some power. So yeah, there you go. I wouldn't stress out too much about the orientation and tilt, basically, except if it's totally flat, then it's more likely the water and dust is just going to build up and it's going to end up getting dirty. If you have at least 10 degrees, then it's more likely that like rain is just going to automatically wash it. It's not guaranteed, because like, I think it depends on what kind of dirt you have, what kind of dust. Like, is it like clay dust that's going to like build up like sticky clay on your panels, or is it like sort of sandy or loamy that's just going to fall away? Or do you have birds with particularly sticky poo or gum trees or whatever, right? So specific situations do matter, and winds and all that. But most people find that they don't need to clean. If they've got a bit of a tilt on their panels, it's okay. It's just automatic. heritage restrictions. So if your council is saying, oh, you can't do anything to the front of your building because it's such a beautiful old building and it's at the character of the area and all that stuff. Yeah, if that's the case, then you may need to get a planning approval from the council. Will the solar work in a grid outage? If it's just a standard solar system, unfortunately not. If you add a battery, then it can. And there are a couple of solar systems that can give you some power in a grid outage, even without a battery. A specific condition, I can talk about it in the questions if someone asks. Do the panels actually provide shade to your roof? Yeah, they do. I mean, how significant it is debatable, but yeah, like if it's a hot summer day and the sun's pounding on your ColourBond roof and it's heating up your home, then having some panels there is definitely going to help. What do we do with the panels at the end of life? Well, it's not as much of a problem as some social media things make out. I mean, at the end of the day, it's a sheet of glass. They're not that toxic, like the stuff in it. There were some panels like from 20 years ago that had cadmium in them, but that's ancient history. That's not a factor now. So yeah, there are recycling facilities. They haven't really fired up yet, and that's basically just because of the incentives. Like it needs some regulation, like what they have in Europe. So to force manufacturers to like have a responsibility to take back their old stuff at end of life. That's what we really need. Okay, how do you get the most out of your solar? Well, how do I get the most out of my time? I've kind of gone over a bit. I might just have to power through this section fairly fast. But basically, a typical household, if they're like studying or working or whatever, then they tend to not use that much power in the middle of the day, but they use more in the morning and evening. And it's sort of a mismatch with your solar. Now, it's often not as drastic as what this picture would show. This is just a cartoon version, right? And energy use, it varies a lot. Like, are you home during the day? And the type of electricity usage varies enormously. Like, there are people who bake and cook all the time. There are people who have like all sorts of electronic gadgets, mining cryptocurrencies and running servers and whatever. It's people with pools, pool pumps, pool heating even, charging electric vehicles. Like there's so much variety now. It's hard to say, well, what's the standard? But yeah, if this is you, then you would have excess solar in the middle of the day. Okay, how do you use that? Heating water is a really good one. So that could be an old-fashioned resistive electric hot water system that just has a tank with an element in it, like a kettle, basically. Or it could be a more efficient, more modern electric hot water system, like one of these, a heat pump hot water system that works like an air conditioner or a fridge. Only uses about a quarter as much electricity. But yeah, it's still a really good way to soak up power and store it in the form of hot water for your shower for the next day or two. You can run your clothes dryers, washing machines, all that stuff. Pool pumps is a really good one. If you've got a pool with like pumps to run the filters and things, and that, yeah, try and do it in the middle of the day if you've got solar. Could you pre-cool your home? So run your aircon hard in the middle of the day when it's sunny, so your home would stay cool in the evening. Maybe, but only if your home is like well sealed and well insulated. If it's not, then yeah, that cool air is just going to like soak out anyway. So that's a bit of a horses for courses. And EVs, of course, if you can charge an EV during the day, that's perfect. Okay, batteries. Now, this picture is from back in 2015 when the original Tesla Powerwall was released. And this family was one of the first, if not the first, to install a Tesla home battery in Australia. So, yeah, I've been monitoring what's been going on since then. And yeah, ever since then we've been saying, well, they're not really economic. I mean, back then there was a lot of hype, but yeah, working at Renew, yeah, we were saying, well, yeah, they're not really economic. And if you look at the forecast, then by 2020, maybe there'll be, yeah, battery prices will come down, and that's when they might be economic. Still didn't happen. Still really hasn't happened yet. Battery prices have come down a lot for other things like massive batteries in the grid and for EVs, but for home batteries, unfortunately, the prices still haven't come down. I think there's a fair bit of profit taking in that market, but hopefully it's going to happen soon. So why get it? Yeah, store renewable energy for later. So you're saving money on your bills. Can help with local grid issues. So in some ways, it can help you to, if your solar system keeps getting throttled around the middle of the day because your poles and wires have trouble, like in your street, have trouble when everyone's exporting, then having a battery can help with that and help you get more value. Go off grid, so sever your connection to the grid totally. If you have a grid connection already and you're sort of in a reasonably built up area, then it probably doesn't make sense. If you're way out in the bush and you've got a very skinny line, or you don't have a line and it would cost you tens of thousands of dollars to have the poles extended to your house, then going off grid might make sense. Okay, so same picture as we had before, but now we've got a battery here. So this is one example where the battery is connected in directly to the solar inverter. That's one option. There's another way that you can connect a battery, where the battery could be over on the other side of the house, and it just connects straight into your switchboard because the battery has its own inverter with it. So, and that's what the recent Tesla Powerwalls do, the Tesla Powerwall 2 and 3. So yeah, there is some flexibility on where you can put a battery, but not total flexibility. The Australian standards basically say you're basically limited to putting it on the external wall of a house, and you can't have windows near it, or gas bottles, or aircon units, or water heaters, or basically anything near it. You need a pretty nice dedicated patch of wall for it, or in a garage. That's really what it boils down to mostly. Done that. Okay, so the idea with a battery is that now when you're generating, some of that energy that would have been exported to the grid goes into your battery, and then that gets used later on to power your appliances. So that's the basic way that you operate a battery. It's just going to charge up when you've got excess solar and then discharge when you have a shortfall. So yeah. Now, a few pitfalls to avoid. Yeah, if you want blackout backup, definitely specify that you want it, and what type of backup as well. If you want blackout backup for a grid outage, then make sure you've got the battery's big enough to last as long as what you want it to power the appliances that you want to power in a grid outage. Inverter limit, yeah, that's something for your installer to work out probably. This is what I've talked about, the location. Yeah, you don't want to put a battery or even a solar inverter like right on the western wall in full sun, because anything electronic or chemical, like they don't really do that well, like when they're heated up, like every hot day. So yeah, try and give them a bit of shade or something. Yeah, warranties, I'll talk about that later. So if you're looking for more information on batteries, then come to the next webinar coming up. Or we've also got these other typical sorts of resources, and the Victorian government also has some pretty good info these days. Now with batteries, there's, apart from just storing your own solar to use later, there are some trickier things that can be done with batteries. So, um, and this is about basically helping the grid when the grid needs a bit of help, because the wholesale electricity market, you don't see it on your bill, but it's like the stock market. It jumps around to super high amounts and then it can go negative. So, for example, virtual power plant. Okay, basic example is your electricity retailer, so Origin, AGL, whoever. They do a deal with you, and maybe they give you like a discounted price on installing a battery. Um, but in return, they get the right to mess with your battery occasionally, to send it a signal to like stay charged. And then in the evening, when they've forecasted that the wholesale price is going to shoot up, then they tell your battery to discharge. And then because your retailer has to pay for electricity off your related to your meter, if you're exporting through the meter, that saves them a lot of money on the wholesale market, which they're exposed to, but you're not. So it helps them save a lot of money just at those times when they can take advantage of it. So yeah, in concept, that's a good idea. Like if they're only doing that a handful of times a year, maybe, then it doesn't bother you too much. But it gives them a big benefit, and then they give you a benefit, maybe a reduced price on your battery. So that's a typical example. Basically, you have to read the fine print. If you're signing up for one of these deals, then yeah, what are all the terms and conditions? Yeah, that's enough for now. Okay, buying a solar system. Okay, think about how much you actually spend on energy. Like there are some homes that don't spend much at all. Like if you're really frugal, maybe just a single person, if your bill's really low, then your opportunity to have big bill savings is also fairly small. I mean, it's a great thing that your bill's low, but it just means that you're not going to be saving more than what you're paying already on bill savings, most likely. What type of appliances do you have? Oh yeah, the flip side is if you are using heaps of energy because you've got a big household and you've got all sorts of things going on, then yeah, going solar could, yeah, the savings could be huge. So yeah. Why do you want solar? A few different reasons. And yeah, does your roof get good sun? So basically, like in a nutshell, I would say like if you got a nice big wide space on your roof that gets good sun, and you're going to stay in your home for quite a while, like say more than 7 years or something, then it's probably a pretty good idea to go solar. Okay, so if you want to work out what size, like how many panels, sort of thing, then there's calculators. There's a bunch of those. Yeah. I think either Talia or Renew Tech will put some of these links in the chat for you to access. And then if you're buying a solar system, there's usually like two companies involved. There's the solar retailer. That's the company who you're actually dealing with to buy the solar system. And then you've got the installer, solar installer. So that's the tradies that actually turn up and put the system on your roof, install it. And usually those are two different companies, and the installers are subcontracted by the retailer to do the work. There are still some companies that do it all, like more of yeah, they're usually smaller companies that have been in the area for a long time. They've got a good reputation in the local area, and they'll do the deal. They'll actually take your money and often they'll come out and on site and do a quote. With some of the bigger retailers, they won't. They'll just do everything remotely with off aerial photos and things. So yeah, if that's a good option. If you do have a recommended, like maybe through word of mouth in your local area, a solar company that will install and do all the deal with you, then I reckon that's a pretty good option. And because then they're responsible for the whole thing, right? And there's no pointing fingers at each other, which can sometimes happen if you have a subcontractor. Like I'm sure you've heard of this, even like if you've got a builder doing say a big renovation or something, and then they've got tradies that then, there's always that potential, right? How do you choose a good solar retailer? Yeah, this net CC code of conduct. That's pretty much all of them, I would think. Like there'd be very few that don't have that. So I'm not sure how much of a differentiator it is these days, but yeah, word of mouth's good. There are websites online that can do you can find reviews, etc. Here's Solar Quotes is pretty good for that. Check warranties, which I think we're going to talk about in a minute. Yeah, so how do you minimize the cowboy risk? So, cowboy installer would be one who's not doing a good job and not taking it seriously. And I think in this picture here, we've got conduit just going all over the roof and cables not properly installed. And this is not a real system, by the way. Well, at least I hope it's not. So yeah, that's the sort of thing that you don't want happening. So how do you avoid that? Well, I'd be asking back on that subcontractor issue. So the solar retailer that you're dealing with, ask them how they vet, how they approve, how do they make sure that their subcontractors are doing a good job? Is the solar retailer going to take full responsibility for everything? With the quote that they give you for the solar system, is that clear on where the panels will go, where will the battery, the inverter go, battery if you're getting one, and also like where will the cables go? So, for example, will they be hidden inside the wall cavity, or will they be outside the wall in a conduit? So just be really clear about what the job's going to be like. Okay, and then with the installer doing the job, make sure that they're accredited with the as a solar installer by the Clean Energy Council. So that's an individual. That's not the company. It's an individual that has that accreditation, and they need to be there on the job. Well, maybe not all the time. The other guys without a qualification can do some of the work, but that individual should be there at the key times when the important work's going on. Okay, what exact brand and model are you getting? So you have a solar panel, so it's by some brand name company, and it'll have a model, like a model number. So that'll be in the quote. And the same for the inverter and battery if you're getting one. So just double check that the panels and the inverter that you're getting are the exact same model and brand as what was on the quote. Because what happens sometimes is the quote was done, and then it's a few weeks later when they come to install, and the warehouse they've had a changeover. They've run out of the stock of the old model, and now they've got the new model, and you're going to get that one instead. Well, in that case, it's probably fine. In fact, you may get a slightly better model than what was on the quote, but they should tell you that, right? If you're getting something different, then you should be aware. And yeah, there have been cases where you get a panel that's actually worse than what was on the quote for some reason. So yeah, that's something to watch out for. when they finish up installing the solar system, then as the resident, you should be getting a good handover from the solar installer. There should be some documentation. You should know how you can monitor the system, how you can tell whether it's generating as much as it should be generating, that kind of thing. And warranties. So with the solar panels, you've got a performance warranty. That doesn't really mean that much, actually. Like, they pretty much all have a performance warranty. And then there's a product warranty. So that's like, if the panel's going to actually start falling apart or something, right? That's what the product warranty covers. These days, they're usually 20 or 25 years for solar panels. So yeah, solar panels do last a long time. So, and that's proven, like, over time now. So that's good. But yeah, so there should be a good warranty. And then the installation. So that's if the installer didn't tighten up all the connections on the box properly or something like that, then, and something goes wrong, then is that covered as well? Okay. So that's the end of the presentation. Sorry, I have gone over time, but going over to questions now.
Yeah, thanks, Andrew. That was great. I'm sure there will be a few questions, and we'll get to that shortly. So if anyone has any questions, please feel free to put them into the Q&A function now. Before we get to that, I'd just like to mention that tonight's webinar is the first in a series of online and in-person workshops that we have running throughout 2025 called Living Lightly. So we're partnering with Bass Coast Adult Learning, as well as other organisations like South Gippsland Shire Council and Renew, to deliver these, and it'll be covering topics such as energy, food, gardening and circular economy. You can register for them for free now. There's a session on Sunday on using and avoiding leftovers, and that will be at the garden group of Wonthaggi Men's Shed, and the link to register for that will be in the chat, as well as the other webinars and workshops that we have running. And I also just wanted to mention Solar Savers. So Bass Coast Shire Council is part of the Solar Savers initiative, which is a local government initiative that helps households and businesses install quality and affordable rooftop solar and batteries. They also do heat pump hot water systems and some other things as well. They've installed over 600 solar PV systems in Victoria since 2019, and there will be a link to that in the chat as well. So if you're thinking about installing solar and you're not sure, you know, who to trust or that, you can go to them, get a no obligation quote, and they're also very happy to answer questions. So it's a good starting point. Right, well, let's see what questions we have.
Well, I can answer one of my own sort of questions that I mentioned in the webinar if you'd like me to.
Yeah, go for it. Otherwise, I've got a couple others here as well. So.
Oh, you do? Okay, let's go with them
then. One of them, which I think you've partially covered, is just with talking about the feed-in tariffs. Do you think it's worthwhile getting larger systems than are required, or only what would be required to use for the actual household?
Yeah, that's a very good question. The tricky thing with that is that not every day is the same, okay? So there are some days when the household is using a lot of energy, like maybe you've got a party on, or I don't know, you're doing heaps of vacuuming, or you're in the workshop running lots of power tools, or whatever it is, right? And then there's other days when you're not using much energy, like maybe you've gone away. So that's one variability, and the other one is like how sunny it is. So like on a sunny summer day, you might be generating 8 times as much energy over that day than you would on like a really cloudy winter day. So when you combine those two variables, like you could have a sunny day when you're not home, yeah, you're going to be exporting no matter what size your solar system is. Or if you have a cloudy day when you're using lots of energy through the day, well, you're going to be importing from the grid, no matter how big your solar system. Well, pretty much. So so it's pretty impossible to get it just right. So you're never importing, you're never exporting. I mean, even if you have a battery, like the size of the batteries is not, it's not enormous. So yeah, you're still going to have some exports and some imports. So yeah, it's yeah. Look, if you go really small on the solar system, like if you only get a few panels, then that system's going to be uh, most of its generation is going to be used by your appliances directly. So that energy is going to give you a really good saving on those kilowatt hours, but it's not going to generate many kilowatt hours because you've only got a few panels. And it's going to be relatively expensive per panel to install that. And because if a solar installer is going to the effort of doing the deal and the quote and covering all their overheads and getting up on the roof and travel and all that stuff, they're going to have some fixed costs, which they're going to be charging whether you're installing 3 panels or 50 panels. So yeah. 3 panels install is going to end up being pretty expensive, right? So yeah, like a typical solar size is like 6 kilowatts of rated power, so like 14 panels. That's actually pretty good, I think, in terms of a sort of a sweet spot for not too expensive per panel, like because if the solar installer is there doing the job, then yeah, works in pretty well with your most of the export limits for the poles and wires. I think that's a reasonable sort of starting point for a size. If you have a really big home and you've got pools and electric vehicles and all kinds of stuff, and your hot water is electric and your cooking and your heating is all electric, and then yeah, you probably want to basically go as big as you can, like just fill up the sunny areas of your roof, I would say, like if that's you. If you're only a single person and you don't use that much electricity, then yeah, maybe 3 kilowatt solar system, like maybe, I don't know, 6 to 10 panels or something might be okay. So yeah, it's not an exact science. Like it's not really about putting the numbers in a calculator and optimizing it down to, okay, I want a 5.23 kilowatt system, which is 4.6 panels, and they have to be north facing at 20 degrees. I mean, that's not real world, is it? So yeah, just yeah, I'd say just work with your roof and your situation and your future situation. Like if you're planning to buy an electric vehicle in the next year or two or something, then, or even the next 5 years, then yeah, go a bit bigger, because, well, assuming that you can at least once or twice a week you can charge it up at home, then yeah, that's good. But yeah, anywhere between 3 kilowatts and well through to 6 or 7, or would suit like most sort of typical kind of homes. And then if you're using heaps of energy, then yeah, the sky's the limit.
Yeah, thank you. The other question I had was, what's required to be able to have a system that operates in power outages? So if someone has like solar panels and a battery, is it just an inverter that needs to be different? Yeah, how does that sort of work?
Yeah, that's a good question. So Okay, the first sort of level, um, eh, without going to too much additional expense, there are some solar inverters that have like a dedicated power point, right? So they work like a normal solar inverter, but on top of that, your solar installer will put a cable like into your house, and they'll connect that cable to a normal power point on the wall somewhere, and that power point we will only work in a blackout. So it's a bit weird. Like, so if a blackout happens and it's sunny, right, then all of your other power points will stop working, but that one will start working because it'll get some power directly off your solar panels. So that's a pretty good feature. If there's only a couple of brands of inverter that can do that, as far as I'm aware. Um, and it's only going to work when it's sunny, and it's the amount of power you can draw is limited by how sunny it is and what your inverter is putting out. But yeah, if well, it's a PowerPoint, so say if you just run a fridge and your internet router and a laptop and a few things, then that's already a massive benefit in a blackout, isn't it? Right? Even if it's just through the
Yeah.
day, like if you can run your fridge and your freezer through the day when it's sunny, and then it'll still keep your food cold for through the night. So yeah, that could be the difference between losing a fridge worth of food or not. Um, and it could be the difference between being able to work from home and make money that day or not. So um, yeah, so that's the first level. And then the next level is adding a battery. So
Mhm.
so if you're going to add a battery, then um, if it's going to power your house, then it has to be set up in a way that like your house is going to run its own little grid. So and it has to have like a switch put in that's going to there's a blackout, the switch has to open up so that it islands your property from the grid and it runs its own little grid, because you don't want to be discharging your battery and trying to power your own house and also trying to power your neighbors because that well, firstly your battery's going to run flat pretty quickly, but also there are safety issues if you're power into the grid, like when it's not meant to be power in the grid. So yeah, the solar installers have to do a few things if they are going to run like in a blackout. Yeah, it has to have that switch that disconnects it, um, and you have to have an inverter that's capable of running appliances in a blackout. Because like a normal solar inverter, it it's all designed to work together with the grid, like they're helping each other. But if the grid's not there, then the solar inverter, like if you're on a clothes dryer or a vacuum cleaner or something, and that sudden surge in power, a normal solar inverter can't really cope with that without the grid being there. So yeah, you need to have yeah, equipment that's going to run during a blackout. So it could be a solar inverter by itself that has those capabilities and it has a battery hooking into it, or it could be a separate battery which has its own inverter. So an example of that would be the Tesla Powerwall 2. I mean that's the one everyone's heard of, and yeah, it's been around for a long time, and it's been proven to work well. But there's plenty of others, but just as an example. So something like that, yeah, it can run during a blackout. Next question is, will the battery charge up from the solar during a blackout? Because some of them won't. You have a grid blackout, and okay, your battery's powering, but it's when the battery goes flat, that's it. It's not charging up. So yeah, ideally, you really want the battery to be charging up when it's sunny. Um, and then yeah, that's basically it. Oh yeah, the other one is like when you have a blackout, how quick does it cut in? Like for most people, that probably doesn't matter too much. If you get blacked out for a couple of seconds, okay, your internet goes down for a couple of seconds, okay, but if that's really critical to have a instant like changeover from grid to your own battery, then there are some systems that can do that as well. So those are the questions to ask.
Yeah, great. Thank you. Did you mention that you had something else you wanted to talk to?
How are we going for time? Like what time was the
We've just got 3 minutes left.
yeah, we don't have time for what I was going to rant about.
Yeah. All right. No worries. Well, thank you very much for all of that. It's very, very interesting. And thanks everyone for your time tonight. I hope that this has been informative and has been able to answer some of the questions you might have had about installing solar. A special thank you to Andrew, our expert presenter tonight. And also thank you to Sarah from Renew for the behind the scenes support. Before we close the event tonight, I'd just like to remind you that the next workshop in the Living Lightly series is on this Sunday, the 23rd of Feb, at the Garden Group of Wonthaggi Men's Shed. And there are also 2 more webinars next week on Tuesday and Thursday on water and greening and an intro to circular economy. You can register for any of those workshops and more on our website. The link for that will be in the chat. And just a final reminder that this webinar has been recorded and will be posted on our website in the near future. So you'll be able to find any recordings of our webinars there. That's all for tonight. Thanks again for your attendance and hope to see you all again soon. Thanks.